today is going to be kind of a short video because we're just going to be going over right triangles in the Pythagorean Theorem, and we're just going to be strictly focusing on that Pythagorean Theorem. So, the Pythagorean Theorem states that in a right triangle, note that this is only for right triangles. You cannot use these on isosceles or any of those, right? But it states that a squared plus b squared will equal c squared. And so you might be wondering, okay, well, what is a, what is b, what is c? Like, where do these come from? So our a and our b, maybe if it comes back, there we go. Our a and our b actually come from the shorter sides. So these are the shorter sides. And they're also known as the legs. And I'll show you what that kind of looks like. And then our c is our hypotenuse. And this is the opposite side of the right triangle. And please note that c always is the longest length. So out of your A and your B and your C, your A and your B both have to be smaller than C. So let's draw ourselves a right triangle really quickly. So draw ourselves a right triangle. And so our legs consist of these and this. And then you'll notice how these are both shorter than this length right here, right? And so this can be your A or your B. It doesn't matter because since you're adding them in the equation, they can flip-flop, so it can actually be b squared plus a squared equals c squared. But either way. And then that means that this can also be A or B, but then you have to note that this is the hypotenuse. It's also the longest length, so this has to equal C. So let's try out a few examples, right? I'm not going to draw the triangle for these because, like we stated before, this could be A or B, or this could be A or B, or this could be A or B. So I'm just going to say, like, find C, find B, and all this. So if we say, for example, if we have A equals 6 and B equals 8, and then we have to find C, right? So if we want to draw a triangle, it would be 6, 8, and we're trying to find C, right? So according to our Pythagorean theorem, it would be 6 squared plus 8 squared equals C squared. Now it's important to note that C is squared. So you'll have 36 plus 64, which you would get 100 equals C squared. So we're trying to find C though. So we actually have to take the square root of this, and lucky for us, 100 is a perfect square, and so C just equals 10, right? Let's try finding something other than C. So let's say we have, for example, let's try to find B. So let's say we have A equals 5, C equals 13, and we're trying to find B, right? And so our triangle, it would look something like 13, 5, and X, right? So we're just going to plug this in. So we're going to have 5 squared plus, I'm still just going to put B squared equals 13 squared, right? So now we can just follow this like an algebraic equation. And so you'll have 25 plus b squared equals 169. And you're going to move this 25 over. And then you'll have b squared equals 144. And since we what b equals, not b squared. You're going to take the square root of both sides, and what you'll end up getting is that b equals 12. Now, I want you to notice that in these two examples, both a and b are lower than c. And this always has to be the case. So then if we scroll up here, we see that c equals 10, and then a and b are both less than 10. If you ever get an answer and you notice that maybe b is bigger than c, or a is bigger than c, this cannot be the case. So then just recheck your work backwards or forwards. So let's go ahead and do one word problem. And this is just going to be a really simple one, just so you guys can get a sense of how it would look maybe spread out. So let's say that we have a ladder that's leaning against a wall. So here's our wall. And the bottom of the ladder is 9 feet from the wall. So we know that this is the floor, meaning that this has to be the ladder, right? So if we know that it's 9 feet from the wall this way, then it's 9 feet on the bottom. And we know that the ladder reaches 12 feet up the wall. So we know that this equals 12 feet. So just like our other examples, this looks like an Pythagorean Theorem right triangle. So what we would do is do 12 squared, or you could do 9 squared. I'll show you both ways in this to kind of show you that you do get the same answer. So you'll do 12 squared plus 9 squared equals c squared. And what you'll get is 144 plus 81, equals c squared. And, and you'll get 225 equals c squared. And when you take the square root of both sides, you'll get that c equals 15. So just to show you that you can do it either way, you could also have a 9 squared plus 12 squared equals c squared. And again, since you're adding it, it does not really matter because you'll just get 81 plus 144 equals c squared. You'll still get 225 equals c squared. And then when you take the square root, you'll still get 15 equals c. So that's just how it looks as maybe a word problem. You really just want to, when you're dealing with word problems, try to draw it out. It can be a little tricky drawing or putting it in your head when you're given words. So just try to draw it out and try to make it make logical sense, right?